Now I would like to invite our next speaker, Mr. Chris Williams from IBM Watson Europe.
Thank you. Good afternoon, everybody. Who here has heard of Watson? Actually, you should all have heard of Watson because, of course, it was referenced in the last talk, which is great. So I'm going to talk to you a little bit about big data meets AI, partly because of what this conference is about, and partly actually because that's part of my own personal experience. I was up until just under 4 years ago, I was a big data guy. I was the chief architect for big data for IBM in UK and Ireland, and for the last almost 4 years, I've been working in Watson. So I'm going to share with you a little bit of my experience and a little bit of the things that I've learned about AI, and try and relate it to my previous experience in the world of big data and how the two things kind of fit together. So we'll talk a bit about big data and kind of what's missing from the world of big data and how AI and machine learning might try and plug some of those gaps. Of course, I'm going to talk to you quite a bit about Watson and what it is and what you can do with it, and hopefully inspire you all to have a look and do some things for yourselves with our Watson platform. Has anybody in here tried to do anything yet with the Watson platform? Nobody at all. Great. Well, hopefully, as I say, you'll be inspired to go and do so after I've been through my talk. So let's talk a bit about big data. So I was thought I was doing big data before people invented the word big data. My background was in data warehousing and business intelligence and some of those other things that have been around for a while. And when big data came along, it seemed to me that there were kind of some differences to what had gone before. And some of those differences were just to do with changing the model so that it was no longer so expensive to store and analyze data, which meant that you could maybe keep data that you wouldn't have been able to keep before because you wouldn't have been able to justify doing so. Data warehousing had become really quite an expensive business in terms of per terabyte, which was great if you were selling data warehouses like we were, but not so good if you were buying data warehouses. And I think some people were beginning to think, why are we spending all this money on these big shiny boxes? Are we getting enough value out of it? And are we able to justify storing data at those kind of levels? So I think that was a kind of an economic driver for the sort of things that have changed in big data. I think also there was a recognition that we perhaps were not storing some of the data that we should have been in terms of the types of data that there were. Anything that was difficult, we tended to ignore. Okay, and I'll come back to that in a minute. So of course, we had these things about, the 3 V's or the 4 V's. Everybody heard of the 3 V's and the 4 V's? Volume, velocity, etc., etc. Okay, so volume. So are we going to store a lot of data? Yes, right? We've all seen those charts about the volume of data growing and growing and growing and growing all the time, and more data has been generated in the past however many years than has ever been generated before, and more will be generated in the future. So yeah, sure, part of this is about a volume game. All of the things that we've been hearing about today around IoT and all the devices and all the other things that we do, which just generate more and more data. So yeah, sure, this is partly about volume. And yes, it's about velocity. I always thought there was a bit of when I was in the big data world, there was always a bit of a debate about what did velocity actually mean. For me, I think it was mostly about the speed at which data arrived and how quickly you needed to do something with it before the information potentially went out of date. So how quickly could you act on events that were happening and take action on them? And that led us into the world of streaming data. IBM was really at the forefront of some of the streaming data technology, and in fact in the not the previous presentation, the one before that, there was quite a lot of talk about streaming data for those of you who were in the room at that point, and there was some real-time analytics happening on the screen based on people moving their phones around. So, you know, if you can capture data, the best example we had certainly in IBM was where we connected a big data, streaming data platform to the sensors in premature baby cribs, and were able to detect infection up to 24 hours sooner than the traditional method, which is, let's face it, it's being done by real experts, but by applying some analytics algorithms, some predictive algorithms in real time to that data as it was streaming off of those. There's about 25 sensors in one of these cribs. If you could detect the early signs of infection and massively improve outcomes in that premature intensive care scenario. So that's and then there's variety, right? So the thing about variety is that I never felt that we really did very much about variety when I was in big data. It always seemed to me that we would always come back to doing the easy data again, right? The data that was vaguely structured, and if it wasn't structured, we'd be desperate to kind of pretend it was or do something with it to make it structured. And we ignored a lot of the hard stuff. We ignored things like trying to really extract meaning from text. We ignored dealing with images and videos and audio and all these other more complex forms of data, it seemed to me. And that's not a comment about IBM, that's a comment about the industry in general. So in some senses, we were just doing what we'd always done. We were just doing it in an environment where it was cheaper per terabyte or per gigabyte or whatever to store the data. And we were storing potentially more of it. But the flip side to that was it was actually harder and you had to write a lot of code. I know some of that's probably been addressed in the last kind of 3 or 4 years since I moved on to doing other things. But it certainly was the case that a lot of the more complex types of data, the unstructured data, the difficult data, as I always used to call it, we tended to ignore. Do people recognize that, or is that something that was just me? Right, that's good. Okay, lots of nods, right? Okay, so why is it so hard to deal with this difficult data, this unstructured data? And I think the reason why is partly this, and partly because we have to interpret it. Now, is anybody in this room call themselves a data scientist? Oh, thank goodness for that. Right, that means I can be really rude about data scientists. Great. So the thing about this is that there's always when smart people start working with data, there's a temptation for them to want to kind of keep it to themselves and pretend that only they can do it, right? Okay. And so a lot of what we talk about in data science, in the same way as a lot of what we talk about in AI, and I'll come on to that in a minute, has been around for quite a while, right? Okay. In some senses, none of this stuff is new. But there's a kind of a protectionism. There's a thing where the people who really understand this stuff are a little bit frightened of giving it to people who perhaps don't have their level of expertise. Okay? And in some ways, that's a legitimate thing, because it's very easy to misinterpret data, right? It's very easy to draw conclusions that perhaps are statistically not significant or not correct. But if we're really going to exploit data, we need to make the algorithms, make the processes, make the techniques available to as wide an audience as possible. Okay. And that really is kind of what started to happen with this big data revolution that's been happening over the past, 5-6 years. Okay, so that's the first thing. The second thing is that when we're in the world of unstructured data, particularly text, because Watson's heritage is in text, and a lot of what we do is in text, but also image recognition and some of the other things which I'll talk about in a minute. We need the machine to interpret that data in a much more human way than when it's just crunching numbers. Okay? We need the machine to have a level of inference and understanding that goes way beyond what a machine would traditionally do. Now, who knows where Watson came from? The story of, well, shout out the word that Jeopardy. Thank you very much. Right. So those of you that don't know, 6 years ago, and yes, it was 6 years ago now, so it's kind of not a recent thing, but 6 years ago we built a machine that competed on this game show called Jeopardy, and that is really the DNA of everything else that we've done and called Watson ever since. And the reason why we did that was because we wanted to show to the world, right, to people who weren't data scientists or machine learning experts or natural language processing experts, what a machine could do if it was built, configured and trained correctly. Now, Jeopardy is quite a hard game even for people to play because, first of all, you have to know a lot. You have to have really a lot of general knowledge. And secondly, you have to be able to very quickly get your mind around some very complex questions which are deliberately worded in a way which is cryptic and you have to kind of unravel. And that's hard even for a person to do. And it's particularly hard for a machine to do. And so to get to this level of understanding, we need to do something that has not really been done before by machines that were in most people's usual experience, and that is to allow the machine to learn. And the reason why we need the machine to learn is because there's no way that we could possibly code or program every possible Jeopardy question into that system, because there are about 19 or 20 different types of question that come up on Jeopardy. We did the analysis. But it can be on pretty much any subject. So there's no way that we can just program, with a great big if-then-else type statement, everything that might come up in that game. And that's true also of a lot of the data problems that we're trying to solve in the real world. If I want to be able to understand and interpret lots of documents that exist in a particular field, in a particular industry, if I want to be able to answer customers' questions, as we saw before, maybe in a retail environment or in any industry, I need to develop a level of understanding which can only be got by teaching the machine things. Okay, I can't exclusively program that understanding in. Come back to that. I'm going to finish what I'm going to say about this. So that, in essence, is what we've been doing since Jeopardy, is taking those ideas and applying those in the business world. And I'll come on to a minute in how we do that and what that platform actually looks like. But first, let's take a little step back and think about machine learning and kind of its history and AI. Now, machine learning and AI have been around for a long time, probably since the 1950s, maybe even before that, as concepts. And they've been things which have been looked at by smart people, typically in academic circles, who have tried very hard to build algorithms that can do some of that kind of understanding that I was talking about, can learn, can tackle tough problems. Okay? And for a long time, AI and machine learning remained firmly in academia as a kind of a research subject, and delivered very little into the real world. And in fact, you'll hear, if you look at the history of this, you'll hear about people talking about cycles. You'll hear them talking about how there were great times for AI, and then everything kind of dropped off, and there was an AI winter, if you like, where everybody kind of fell out of love with it and said, this is never going to work, we're never going to have AI, it's never going to happen. Now, which brings me on to why there's a picture of a self-driving car on the screen. So, I used to say 10 years ago, it's longer than that now, probably about 13, 14 years ago, people thought that self-driving cars would never happen. It was impossible. It was a task that was too difficult for machines to do, to drive a car. There were too many variables, there was too much going on. You could not possibly teach a car to drive. By the way, my 17-year-old son is learning to drive at the moment. Okay, and at the moment it feels impossible to teach a person to drive, but I'm sure he'll get there. So, so how have we gone from the situation 14 or whatever it was years ago, where pretty much everybody agreed that this was an insolvable problem, to the situation where we're actually pretty close to having self-driving cars? I mean, you can buy cars now that almost drive themselves, and there are, you know, extensive testing of completely autonomous vehicles out there. And there are a number of reasons, right? Some of it is to do with computing power, and some of it is to do with more advanced sensors. But mostly it's to do with the fact that we've learned how to apply this idea of machine learning in the real world. Okay? So we take the test vehicles out and we teach them about scenarios that they meet in the real world. And we tell them when they're wrong, and we tell them when they're right, and then they learn the patterns. Okay? There's no way that you could sit there and write in code, okay, if traffic light is red and there's something coming from the left, and right, then stop, and otherwise, you know, all that stuff, right? Okay, you can't. It's too complicated. So you have to teach it. Okay, so we've talked a bit about this already, about Jeopardy. Now, interesting thing about Jeopardy. So you see what's going on here. There's two people. These two guys are the champions of Jeopardy, the best human players that there have ever been. And there's our Watson machine sat in the middle, or at least an avatar that represents the Watson machine. Watson machine was about as big as this stage of racks. And you think about what's going on here. So we've got these two guys. They are playing the game, and they're doing pretty well. We only just beat these two guys, by the way. It was quite close. And not only are they playing the game, but they're managing to not fall over, right? And their hearts are beating and they're breathing, and probably a little part of their brain is thinking about, you know, what they're going to have for dinner after the show, or shopping lists or something, right? Okay. So, and their brains are only running on about 15 watts. Well, there's lots of people arriving to hear about Watson. Look at that. Fantastic. But we started a bit early, okay? But the best is yet to come. You haven't missed too much so far, okay? So these guys, they're playing the game 15 watts, right? Okay, 15 to 20 watts, maybe, their brains. So, you know, I used to say less than a light bulb, but light bulbs you consume probably less than that now. The machine that took up all of this stage in racks, right, 35 kilowatts, okay? And it's only just managing to beat them. Okay? So we've got a long way to go in terms of building machines that are as efficient as our brains at doing this whole learning thing and this language understanding and all of the things that we're talking about. So, in fact, a lot of the research that goes on in IBM is to do with how can we build machines that are able to do these machine learning type tasks more efficiently, and we've made huge strides in that. By the way, one of the reasons why we had so many racks and, you know, so much electricity was because we kind of used brute force in this scenario. So lots and lots of algorithms, and then worked out which ones were giving the best results. That's okay if you're going to be on TV, right, doing a thing, because a big machine looks cool on TV, right? But of course, in the real world, we don't want that. We want to make things as efficient as possible. So that means that we're doing research not only into better algorithms and smarter ways of doing all this stuff. How do we sort of emulate the human brain better in software, if you like? But also, what are the actual machines going to be like? What are the chips going to be like? You know, so that means studying right down into the biology of the human brain, right down at kind of the level of, you know, molecular chemistry, et cetera, et cetera. So lots of really interesting stuff going on there. But this was 6 years ago, and things have moved on a lot since this. So I'm going to try and focus a bit more on as well on what we can do now. Now, who's got one of these devices? Okay. Okay, lots of people have got them. What do you think of it? Good?
Very good.
Very good, yeah? Can you have a conversation with it, would you say?
No.
Most people, some people are saying ish, some people are saying no. So I certainly don't think you could have the kind of conversation that you could have with a friend or a colleague. Okay? You couldn't kind of debate and get into a bit of nuance and right. Okay, these things are really good at understanding instructions that they've been taught about, and then carrying out those instructions. And to some extent, they can do kind of multi-step transactions, but they can't kind of remember context and sort of develop an argument and carry on through. Okay? The other thing that these things are really good at is understanding actual speech, right? But only in the context of you shouting across the room at them, right? And I think that sort of sets some slightly high expectations of where we are with being able to, where machines are with being able to understand speech. There are still a lot of, and this is a statement about the industry in general, there are still a lot of challenges in understanding speech in real business scenarios. So, being able to listen to what's going on in a business meeting or on a conference call or even in a call into a contact center and really make sense of it, right? To the point where the machine can take over great aspects of it or really contribute. So these machines are fun. Now, we heard about robot in the last who was in the last session. So robots are physical robots are another channel, right? Another channel that we may well use to communicate. And in some environments, they're going to work really well. I suspect in a lot of environments, we probably won't be talking to and interacting with something like this. We'll be interacting with other devices. But they certainly have a part to play in the thing. By the way, we used to have an early version of the Pepper robot that was being talked about, and it used to fall over a lot. I think they've fixed it now. But it was good at dancing, though. Now, before I do any talks about AI, I always do a little quick trawl of the media just to find out what the media are saying about AI. And mostly it's kind of, it's either doom and gloom or it's some kind of sensational stuff, right? Okay. And if you contrast that with kind of the political leadership on this stuff, in the election that we had earlier this year, I don't think any of the main parties mentioned anything about automation and AI in their manifestos to speak of, right? There was very little reference to it in there. So there's no doubt that some of the things that we can now do and will increasingly be able to do are going to have an impact upon society and on the way that we do work. When we talk about AI in IBM, we tend to talk about augmented intelligence. And we tend to very much focus on the idea of machines that help people to do their jobs better. Okay? So we don't think of AI as being about, let's build something that is exactly the same as a person. Okay? We think of AI as let's build a machine that we can put alongside somebody and the machine has expertise. Now, why might we want to do that? Well, there's kind of two reasons. Either the machine has expertise that the person who's using it doesn't, right? So it's a consumer trying to get information and be helped, maybe through some kind of chatbot, conversational type style interface, right? Or somebody who actually is an expert but doesn't know everything and wants help in developing their ideas. Imagine the scenario that you you go to see a specialist because there's something wrong with you, and you look around and you notice some there are some books on a bookshelf there, sort of medical textbooks, and then you have a look at their in tray, and in their in tray are lots of medical journals, and they're all still in their shrink wrap. Right? And you think to yourself, well, what happens if the best treatment for the condition that I've turned up with is buried away in either one of those books that this person hasn't read for years, or is in one of those journals that are still in their shrink wrap. So the idea is that Watson can read a lot more information than a person ever can, and then be able to surface that expertise and that information based on the latest and greatest information because it's been taught how to, and help the expert come alongside them. And that's applicable across all kinds of industries. Okay, so the idea that we create augmented intelligence. And very specifically, Watson is an AI platform built for business. So we're not trying to be a kind of a toy for consumers, if you like. We're trying to solve business problems. Now, that may, in some cases, mean building B2C type applications, but it means that we don't have to be able to be a kind of general purpose, general knowledge kind of AI. What we want to do is to solve very specific business problems. So a theme that runs through the way that our platform is built is, first of all, that the training that an organization puts into that platform is theirs, right? It's not shared with anybody else. Okay, so we're not building this kind of general, let's make sure we know everything about the world. We're creating individual instances of Watson that have been trained in very specific industries, very specific domains, for very specific clients. And we make that available in a way that is very consumable in a business context. So we allow business people to train the system, configure the system, and make it work. And that's really important. It goes back to what I was saying right at the beginning about big data and how, the kind of this idea of kind of keeping this all to yourself. That's not what we're trying to do. We're abstracting everything up a layer. So you don't have to be an AI expert. Your organization doesn't have to employ experts in AI to make this work. Your organization has to take its own knowledge and expertise and use that to train the system using the tools that we provide. Okay, so that's very much where Watson is now. Okay, so who's using it already? We start at the top with RBS. We put a little rosette on there because RBS recently won an award as the best cloud project in the UK, the Computing Awards, about 2 or 3 weeks ago. If you are, is anyone in here a customer of NatWest or RBS or Ulster Bank? A few people, okay. If you go onto their website and you look along the right-hand side, there's a thing that says Need Help. If you click on that, it will connect you to a conversational system powered by Watson that can answer questions. And what it does is it answers a lot of questions for itself. When it doesn't know the answer, it will either point you at the relevant information that will help you to answer your question, or it will actually put you through to a person still within that same channel. The moment it's on the website, it's going to be in the mobile app soon. Okay, it's called RBS Assist, and as I say, it's an award-winning project. Vodafone are doing something very similar with their customer service, and you can also make use of that. The North Face have a really cool Watson-powered app that helps you to buy jackets and other things online. And what it does is it starts from not trying to guide you through a product catalogue, but it starts by having a conversation with you about what are you going to do. So what activity are you going to do? Where are you going to do it? What time of year are you going to do it? These are the things I think you need. Okay? Exactly the same as you might go into a store and say, hey, I'm going camping in South America and, I think it's going to be like this and I'm going to go up some mountains, and that person would advise you in exactly the same way Watson is able to do that. Has anyone here ever heard of H&R Block? Okay. 1 or 2 people who presumably, probably you've lived in the US. Okay, in the US, many people need help to make their tax returns because it's very, very complicated. And H&R Block are one of the main kind of mainstream high street providers of that service. They are now using a Watson system, which actually both the advisor and the customer are seeing information from Watson. So it's kind of Watson sitting alongside them and just helping to guide that process. Okay. Woodside is an oil and gas company in Australia. And they have the challenge that they've got years and years and years of expertise in putting oil and gas installations into really difficult places, so platforms and rigs and pipelines, etc., etc. But all of the people who have the deep expertise in that stuff, eventually, right, they retire. So what happens to their expertise? It retires with them. So what they're doing is they're training a Watson system with all that knowledge so that the less experienced people who work there can draw on that and get access to years and years and years of knowledge and expertise. How many fish are there in this picture? Lots, right? Okay, that's the answer, lots. Okay, so a pet retailer came to us and said, we went through our usual thing. What problems are you trying to solve? Would you like a nice conversational people to help people to buy the right pet? No, they said. Our biggest challenge at the moment is stock keeping in fish tanks. Okay? And it's really, really hard to count fish. Okay? And because, as you can see here, right, and they're quite annoying fish because what they do, sometimes they die, which is sad. Sometimes they have baby fish overnight. So sometimes there are more fish in the morning than there were in the evening, right? And also, of course, people come along and they buy the fish, which is good. But if you want to have a proper inventory of how many fish you've got, which you need to do really, partly for restocking and partly because some of these fish are actually quite valuable, you need to work out how to do that. Now, of course, those of you who have come here thinking that this is an IoT session, right, you're probably thinking, well, we can put a few sensors on these fish, right? Okay. Maybe we could have the Internet of Fins, right? Okay. So, but unfortunately, that turns out that's not possible. So, what we did was to train a Watson image classifier, okay, or in fact a series of Watson image classifiers to recognize how many fish there are in the tank. Okay, and you don't have to know down to the nearest one fish. You have to know, to within maybe 10 or 20 fish. Okay, so, and that's what we did. So, and in fact, there are already cameras, CCTV cameras, so we already had the images. So all we had to do was to train the classifiers in how many fish there are. Okay, so using this idea of machine learning again, but this time based on images, okay, to understand how many fish there are. Now, are you the next guy who's going to speak? Yeah, right, and you're from Belron, right? So am I allowed to talk about what we're doing with Belron? Okay. I thought I'd better check, right? Okay, so Belron are auto glass in this country and the equivalents in lots and lots of other countries, just about every country in the world, I think. Yeah. 35, there you are. Okay, I'm not going to steal all of your thunder, don't worry. And we've been working with them on using similar techniques to this as to how to identify, well, both in glass in vehicles and also in the bodies of vehicles, what the level of damage is. And in the case of windscreens, the big question is always, do you have to replace it or can it be repaired? In the case of bodywork, it's all about, well, first of all, can it be repaired on the driveway? And secondly, what type of expertise do they need to send out to fix it, ranging from, tiny little scratches right through to quite big dents. And in fact, you've gone live, sort of, haven't you already, with a self-service application where people are uploading pictures of damage to vehicles and effectively booking an appointment based on the machine learning that's been done there. And there's more to come. Okay, so finally, before I take a couple of questions, let's talk about these Watson services. So you can access these Watson services and do interesting things with them by going onto IBM's Bluemix Cloud. Okay, sign up and start playing with these. All of these services are cloud services. You access them through APIs, and many of them come with tools that help you to train them and configure them. Okay, as I said, remember, it's business people that we want to be training this. You don't need to be an AI expert. You don't need to know anything about algorithms to make this stuff work. These are not the only services and APIs that you'll see on there, but these are kind of the ones which are kind of the most relevant, I think. So conversation is the thing that drives those chatbot-style conversational interfaces. But think about it not just in terms of a basic kind of chatbot that can answer FAQs. Think about a really rich new kind of user experience where people are able to interact and ask questions and get their questions answered from all kinds of different sources and presented to them in a really interesting and engaging self-service way. Okay? I sometimes say that if you think about how is customer service going to be done in the future? Well, everybody wants to take out cost. Usually when you're taking out cost, you're kind of trading that off against quality. If you can get this right, you can take out some cost and have a really higher quality user interaction. Discovery is the pattern that I talked about with the shrink-wrapped documents, and also Woodside to some extent is discovery. It's all about taking existing documents, existing expertise, and being able to navigate around it and ask questions of it in ways that go way beyond what you can do with just kind of keyword search and the traditional ways that we've done these things. Really rich exploratory applications to go and find new knowledge and find answers to questions. Vision, we've already talked a bit about the possibilities of the things that you can do with image processing and vision. It's all there. You can play with it. You can train your own classifiers. A feature of all of these things is you can train them to work specifically in your industry, your domain. And finally, speech. I mean, speech, as I said before, is a little bit, I think, behind where some of these other technologies are, but it's catching up fast. So you can have a play with that as well. That's about all I've got to say. I have time for some questions. And there's a lady who's very keen straight away. Look at that.
Great presentation. Thank you. I really enjoyed it. The previous speaker talked about AI is never going to replace our jobs, and there's going to be more demand because of AI.
Yep.
And also, I know you touched a little bit on that. So IBM Watson is building programs that are making our jobs better, not necessarily to replace us.
Correct.
So I'm curious, you coming from a company that built a supercomputer, super intelligent computer that beat human beings in the Jeopardy game. So I'm curious, where do you think the future of AI is going? So if we're training computer, they are smarter than us. Yep. Is it ever going to endanger the human race? And if so, what can we do about it? Thanks.
Okay, so that's a big question. So, so the first thing to say is that we do absolutely believe that the role for machines is to be alongside people, not trying to directly replace them. Okay, there will always be things that people are better at than machines, right? And actually, those are probably the important things in life, right? Okay, like empathy and love and all of those things, right? The thing about the changes that this will mean to society and to our workplaces is that, yes, there will be changes as there have always been, right? As you mechanize and automate and change the nature of the workplace, the nature of work changes, right? That's inevitable. But first of all, that's not going to happen overnight. We're not all going to suddenly wake up and find that, oh, you don't need to go to work tomorrow, it'll come on the news. Nobody needs to go to work today because the machines are going to do it for us, right? It's not going to be like that. The other thing is that right now, and for quite a long time to come, there's going to be some really new and interesting jobs to do which are going to be about training machines, okay? And teaching machines how to engage and how to take on board the knowledge that we all have is something that I don't think we've even quite worked out how to do yet. And I think there's loads and going to be lots and lots and lots of work for people to do in doing that. So there's a huge, there are new kinds of jobs that we're only just starting to realize even exist, which are about, how do you write great words for machines to sort of say or print out that are in line with your brand and your values and all of those things, and how do we do that consistently, right? So that's a kind of creative task, right, as much as it is a technical task. So there's a huge amount of new jobs that are going to be created on the back of this. So for sure there are things, there are going to be changes, but we believe that machines are our best place to help people, not to replace them. Okay. At the back. Here comes the mic.
Hello.
Hi.
I know Watson does natural language processing / understanding.
Yes.
In terms of sentiment analysis, entity extraction, and that kind of things. Where do you see opportunities in NLP in general for the future? Another future-oriented question.
Yeah, so this goes back to what I was saying right at the beginning. I know some of you weren't in here at the beginning, but in the big data context, I come from a big data world, and I was always a little kind of surprised that we did our volume and we did our velocity. We didn't really do very much with variety, and because we didn't, it was too hard, right, to understand a lot of text, right? So we just kind of ignored it. Same with images and other things. I think there is huge scope for understanding textual data that's out there, whether that's what people are saying on social media, what people are saying in reviews about products, what's being written in the media, what's being written in technical and business journals. How do we kind of filter out some of the stuff that's kind of untrue or not corroborated, and how do we kind of join up the dots and try and create a better understanding of what's going on. The possibilities are huge. The technology is getting better all the time, and in particular it's getting better in the sense of our ability to tune and train the models and the classifiers that we use to very particular domains, so that we can understand language being used in different industries, in all of our different clients. Everywhere we go, every time we walk through the doors of one of our clients, there'll be words and ways that language is used in that building that are completely different to how it's used out in the street. So the ability to train a model, we have a tool called Knowledge Studio, which is for precisely that. And the idea is that business people with no deep understanding of natural language processing can, by example and by annotation, just go through and teach the system how language is used, and then it will learn from that and be able to read other documents in that industry, that domain, that business. Okay. Yeah, down the front. Oh, here comes the mic.
The question is around IBM's strategy. I think I heard, I saw somewhere that for 21 quarters you've been losing money quarter on quarter. With the likes of Amazon, Apple, the likes of Uber coming on board and hogging the limelight, what's the mood music within IBM? Do you think that with Watson you can go and recapitalize, you can go and capture some of the market and become a leader again?
Yeah, so I don't necessarily think that we're no longer a leader, but it's absolutely the case that this AI for business stuff, we have also called it cognitive, is another word that we use for this stuff, and the fact that it runs on our cloud platform is the future for IBM, right? That's kind of where we see ourselves going. We believe that we are ahead in a lot of areas of this, particularly in the consumability of AI, and in the experience of actually delivering projects that embed AI into business. And if you think about where we've come from, IBM is a 100-plus-year-old company. Most of the other players in this space are not 100-plus-year-old companies, right? So we have a history of reinventing ourselves, and in particular we have a history of being able to take complex, new and emerging technology and really apply everything that we know about business and how to deliver successful projects. So I can only speak for myself, but I'm very optimistic about this and the future in IBM and in general as an industry. Okay.
hopefully the last question.
Sure.
There's a big influx of data which goes to several focal points, and these are several companies around the world.
Yeah.
And there's a reason for that, because all those AI engines need that data. They are like the petrol for the refinery.
Yeah.
So if you don't have a policy where you acquire that data en masse, how do you go about getting better? Because the businesses will give you some of that data.
Yeah, so the question really is, can you create great AI without having access to the maximum amount of data?
And there's a flip side to that.
Yeah, absolutely. And so, we, as I've said earlier on, our policy is very clear, which is that we create individual instances of Watson for our clients where they don't share data, particularly, of course, with their competitors. Right? And that gives them competitive advantage, and we believe that that's absolutely the right thing to do. What we do is we use the learnings from those to improve the algorithms, right? So although clients can actually tick a box when they call our APIs to opt out of that, if they don't tick that box, then we can use that data to improve our algorithms to work out where it works and where it doesn't. Okay, and we have more than enough data to allow us to do that. Is the reality. So we see it as an advantage that we can tune our algorithms to work very well in these domain-specific spaces, rather than trying to be kind of all things to all people, if you like.
The flip side is, when data will then be generated by the machines for the machines, and therefore the empathic element will be missing. So instead of doing the flowers and being this creative marketing person, the run-of-the-mill person, which has a specific set, will then be taken by Boston Robotics. It just becomes a little target.
Yes, that's right. And I think we are, we're very clear that in one of the things that we have learned in the sort of the few years that we've been sort of doing this for real, is that that there is a real sense in which it matters what you put into the machine, right? It matters what knowledge you use. It matters, in fact, for consumer-facing applications, it matters right down to the very words that you use and how they are phrased, because they will form the answers that will go to, to form the face of your brand. Particularly if you think that a lot of this is going to happen through channels that your business doesn't control. It's going to be through some third-party messaging system. So the only way the only thing that you have control over is the words that you use and the pictures that you present, and the you don't control the screen real estate and the rest of the user experience. So it's absolutely critical that our clients have the ability to be absolutely in control of all the training and all of the knowledge that's put into the system. Okay, I think I'm pretty much out of time. I'll allow my colleague from Belron to come up on the stage. Thank you very much for listening and for coming along.